So when you are talking about telescopes, we're talking about big telescopes and bigger and bigger. But it's not just about bigger, it's location. Top of a mountain. On the top of a mountain, you get better views. Why? There's less air you're looking through. So you don't look through as much air. And so that's less atmospheric extinction, less atmospheric reddening, those other effects that we had. That doesn't apply here as much. Secondly, turbulence in the atmosphere distorts the view. When you go out at night, you see twinkling stars. Well, a time exposure of something, because a lot of these things take time exposure, that twinkling smears the view. And so what happens is the atmosphere smears the view, and so you don't get a good view of things. The other problem is that atmospheric extinction, particularly of infrared light, the infrared light doesn't make it to the ground. It only makes it down so far, and so mountaintops give you the ability to use the near infrared and expand the wavelengths. You get clearer views, you get less other issues, less turbulence typically up here above the topography. So this is really good, but you want to go even higher, because mountains only go so high. You only have so high that you can go in the mountain and still have it accessible. So how do you get even higher into the sky? And so, well, how do you get higher than a mountain? Use an airplane. So now we have an airplane. And so we got this airplane right here. And so NASA actually experimented by sticking a camera and a small telescope into an airplane. It worked really well. So then they took a C-141 military transport and they cut a hole in the fuselage. So now this can fly higher than the mountains and look out. Now, you need a hole. You can't just look out a window, because if you're using infrared light, remember, anything that's warm gives off infrared light. And so that means that if you're not at absolute zero, you're giving off infrared light. And so that this is a problem that we have to deal with. And so anything that's not absolute zero is giving off infrared light. So since the window is not absolute zero, it gives off infrared light. So it's like putting a light bulb in front of your telescope. And so what you do is you instead look straight out into space. Well, that means it's open. So as the airplane's flying, the cabin would be depressurized. And so the astronomers and the pilots would have to wear oxygen masks and parkas because it's cold. But this was named after Gerald Kuiper. And so this was the Kuiper Airborne Observatory, and was a spectacular thing, because what would happen is that you can now fly higher, use infrared light, see things you could not otherwise see. So this was a major step forward. Well, it gets even better than that, because they eventually realized, hey, we got Earth and we got observatories at certain locations on Earth, but sometimes something can only be seen from space from a spot where there's no observatory. So now you just fly the Kuiper telescope there. Now, this was not a very big telescope that was in here. It wasn't a whole lot bigger than the biggest telescope that we got on campus. But it was gyroscopically stabilized, so as the airplane bounced around, the telescope would stay put, and it was movable. So you could fly it places. So this observatory, flying observatory, is what mapped our galaxy, mapped the spiral arms of the galaxy. It discovered that there were rings around Uranus and Neptune. So this was a spectacular instrument. But NASA realized you could go better. And so what they did was they then took a 747 and cut a large chunk out of the back end of it. They put a pressure bulkhead right here, and so the forward half is actually pressurized. This thing can now fly much higher, so you can actually fly into the stratosphere. In fact, it's called the Stratospheric Observatory for Infrared Astronomy. And so it is able to fly even higher. So it is based out of Ames Research Center, NASA Ames Research Center in the San Francisco area. And so it flies vastly higher and is able to see things with an even much larger mirror right here. And so this is a much more capable instrument than the Kuiper ever could have been. And so it is now even higher. And so the question, though, is, this is so much better, but can we do even better? It still has to look through the atmosphere. A lot less atmosphere than previous telescopes, but it still looks through the atmosphere. Can you get where you don't have to worry about the atmosphere at all? And the answer is, well, yeah, of course you can. Lyman Spitzer originally was at University of Texas at Austin, and then moved up to Harvard, I think it was. Harvard or Yale, I forget which one. But he suggested, long before the very first satellite was launched, so he suggested this back in the 1940s, that if you launched a telescope into orbit around the Earth, it would not have to worry about atmospheric effects at all. And so this was a very fantastic idea. Was sort of experimented with during the Apollo missions to the moon, in which they set up a camera with a telephoto lens and pointed it up into the sky and took some pictures. So that proved the idea was even possible. After the Apollo missions were over, NASA had 3 leftover Saturn V rockets. Congress cut the Apollo missions budget after we already had 3 moon rockets. So what they did was they took one of those moon rockets and took the 3rd stage of it and turned that into an orbiting laboratory, which was launched into orbit around the Earth in the 1970s. So for a couple years here, this was orbiting Earth. 3 Apollo capsules came up to visit it on smaller rockets and docked with it, and astronauts lived here for about a month at a time and did observations. On board was a telescope that the astronauts could use and connect instruments to, and that proved beyond a shadow of a doubt that even this tiny telescope that was located aboard Skylab was equal to the biggest telescopes on Earth in terms of sharpness of view, and because it had no atmospheric distortion, and could see wavelengths that could not be seen from Earth. And so one of the things discovered here was that the sun is not absolutely constant in its energy output. In fact, there's a term we use in astronomy called the solar constant, which is the total energy output of the sun, and it turns out it's not constant. So they launched another satellite called the Solar Max, because it was launched at solar maximum, because the sun goes through cycles of activity, and we launched it right at the maximum of one of those cycles. And so this was the Solar Max satellite, which ran for most of the 1980s rather, and was geared looking at the sun. The other space-based telescopes were launched, but the one that when you think of as a space telescope is the Hubble Space Telescope. This was the largest of the space telescopes launched. Was so big they would launch it out of the space shuttle, and so the space shuttle took it into space and dropped it off. Now the problem here with this is that it was never designed to stay up there all by itself. As things orbit the Earth, we have Earth, and then we have Earth's atmosphere, and this thing orbits out here, but the atmosphere is air. Air molecules wander around, and so even though this is in space, a couple hundred miles up, it bumps into the occasional stray air molecule, which slows it down and causes it to spiral backwards. Skylab was in a little bit lower orbit, and it spiraled backwards to Earth and splattered itself all over Australia and the Indian Ocean. In fact, chunks of it actually hit buildings there, and they sued the United States government for flaming bits of debris falling on them. Hubble telescope was never meant to stay up there by itself. It was actually designed so that about every 3 to 4 years, the space shuttle would come up here and visit it and push it to a higher orbit, and then take out old parts and put in new replacements. Computers wear out, cameras wear out, other instruments can be improved by later generations of instruments, and so it's designed to do that. Well, the problem is we have not had a space shuttle flying for almost a decade, And so it is gradually spiraling itself down. Now, the original plan was when its mission was over, the space shuttle would go up and grab it and bring it back to Earth and display it in the Smithsonian. We don't have a space shuttle anymore, so that's not going to happen. So the plan was that private companies would build spacecraft that would go up here and eventually push it back to Earth in a controlled mission, so that it doesn't just splatter itself randomly somewhere on Earth, but you push it so that it lands in the Pacific Ocean or the Atlantic Ocean or someplace where you know it's not going to hurt anybody. We have not had much luck in private companies building spacecraft that could do that, though SpaceX now has a manned spacecraft. So that does raise the possibility, though the Dragon spacecraft was never designed to service a mission of this sort, so I'm not sure that that would really work or not, but at least we now at least have a private space company. Okay. There are other space telescopes that are up there. Some are designed just for infrared, some are designed for X-rays, some are gamma rays. Remember, X-rays and gamma rays don't even make it to the ground. And so if you want to look at those wavelengths, you have to go into space. And so there are a number of space telescopes up there. Again, the way you gather the light is different for different kind of telescopes, but you do gather light, you do focus the light, you do things with it. And so even if it's not visual light, you're still gathering light. Hubble telescope is coming back to Earth eventually. It's got to be replaced. We are working on and nearly finished with the replacement for it, which is named the James Webb Space Telescope. James Webb, actually early NASA administrator. And so the James Webb Space Telescope, they realized you don't need the big tube here. So the mirror is going to be open to space, and you have a big sun shield that protects it from the sunlight. Rather than putting it in low Earth orbit, this is going to be taken to a position that's farther out even than the moon. And so that's going to be our next big space telescope. The hope is it's actually going to be online before the Hubble telescope dies. One problem is it's going to be in a place where we cannot service it or fix it. The Hubble telescope, if something breaks low Earth orbit, the plan was that the space shuttle could go up and fix it. We no longer have a space shuttle, so that plan doesn't really work. But we have no spacecraft that can reach out this far, and so if it breaks, it's dead. But that's the replacement that's going to be coming for the Hubble telescope. Here's a graphic that shows you all the different kinds of telescopes here. The Yerkes refractor is this little baby thing right up in here. Okay, it was at one time with the world's largest telescope, and then the 100-inch Hooker telescope at Mount Wilson that George Ellery Hale built, and then finally we have the Hale telescope right here. Multiple mirror telescope right there, and it simulates that dashed circle in the middle for the size of the mirror. And eventually we got the Keck telescopes up here. We've got the Hobby-Eberly telescope right here, and the large binocular telescope. These two telescopes coming together to make it something like that. In South America, there's something called the Very Large Telescope, which is for a telescope simulating a mirror that size right there. Okay. They're working on other sort of things here, so that's the Very Large Telescope. In Hawaii, they've gotten approval to build something that's going to be 30 meters across. That's the 30-meter telescope. And then in the Southern Hemisphere, they are working on, and it should actually become active in the next couple years. European Space Agency is building something called the Extremely Large Telescope. And there it is right here. Now, at one point, they were looking at building a telescope that was this size right there, but they ran out of money for the project. It's been canceled. The working name for that was the Overwhelmingly Large Telescope. And so, again, astronomers are not very original in how we name stuff. My wife teaches biology, and she kind of, rags on us because, we have a large telescope. We call it a large telescope. A 30-meter diameter telescope, we call a 30-meter telescope. But that's just how we do things.